So what is product rule? Product means two things times each other. And in this particular case, that we want to have two function times each other. If it's two function times each other, you can use product rule to take a derivative. And that's a nice thing about it. So let's just say if I take a derivative of this function, let's say if I have d to the dx of some type of f of x times g of x. Then that's equal to derivative of f of x is going to be f prime of x times g of x. Okay, does that make sense? Not yet. So that's not make sense yet. So this part is going to be blue. Okay. So I color code for you. Those are blue and red. So at first I'm going to take a blue function and take a derivative. And plus, and I'm gonna leave the blue function alone, which is f prime of x times g of x. And that is the derivative of f of x times g of x. And I color code for you, and that's that. Now, some people think, and I just, yes. Oh, sorry, it's the other way around. So g prime of x. Okay, thank you, Matthew. So derivative of f of x times g of x equal to f prime of x, g of x plus f of x times g prime of x. Some major misunderstanding from student usually says they just distribute it. They just f prime of x times g prime of x, and that's wrong. So it's not any of those things. Okay. And so what we're gonna do is we're gonna show you a new way to remember this is right d left plus left d right. Okay, so right d left plus left d right. So you take the right function, you leave it alone, and you take a derivative of the left hand function, and take a left alone, derivative of the right. And that's the best way to think about this is in this perspective, it doesn't matter which order first, because since it's adding, it doesn't matter if it's 2 plus 3 or 3 plus 2. It could be left d right first or right d left first. It doesn't really matter. So now I'm going to take a derivative of two functions in terms of this. So I'm going to say, hey, let's take a derivative of 3x plus 4. And then let's take a derivative of the 3 minus 6x squared, something like this. So they are two functions multiply each other. I can use this product rule to get the derivative of this two function multiplying each other. So first of all, I'm going to take a derivative of the 3x plus 4. So it'll be 3. And I'll leave the second function alone. It's going to be 3 minus 6x squared. And then let's take a derivative of, let's leave the first function alone. And take a derivative of the second function. What's the derivative of the second function? What is it? There you go. So that's equal to 9 minus 18x squared. And this one's going to be minus 36x squared. And minus 48x, right? So it'd be negative 54x squared minus 48x plus 9. And that's my final answer. Now, some people is going to say, hey, look, I don't have to use product rule. I can get an answer. It's going to be quicker. I agree with you. I don't disagree with you. A matter of fact, I'm going to show you how to do it. It is quicker, but for today's homework's purpose of the homework, you have to use product rule because you got to learn how to use it. Because later on, it's not just a product rule. It could be like, so for example, if I teach Daniel how to box, I cannot just teach you how to do a jab. You can jab all day. You're not going to punch nobody. You're going to learn how to hook. You're going to have to learn an upper hook, a right hook, left hook. You got to learn all kind of stuff, right? What other moves are there in box?
Southpaw.
Jabs.
Yeah, the jabs, just power punches, knockout.
Yeah, power punches. You can block. Yes, you have to learn all this combination. So right now we teach you how to do power rule. That's a very powerful move. However, you gotta learn how to jabs. You gotta learn. Depends on the situation. When you're learning a jab, it's usually to have people. It's kind of like a feint. You want people to dodge, and then you throw in a right punch or whatever. And that's the idea. So learn how to do it. Now I'm going to show you how to do it if just distribute it. You're going to find out that's much quicker. So without product rule, it just had to distribute. So that's going to be 9x, right? Minus 18x to the third, I think, plus 12, and minus 24x squared. If I take a derivative of this, what will happen? Well, let's take a derivative of this. If I take a derivative of this one, it's going to be minus 54x to the second, right? If I take a derivative of that, it's going to be minus 48x. If I take a derivative of 9x, it's going to be plus 9. It got to answer so much quicker. You're going to say, I prefer to use this rule. Unfortunately, life's not always this way because later on you're going to learn chain rule. And that's going to be very, very powerful move. That's actually the most powerful move. So you have to learn how to use this. So let's try product rule first. Let's say 2x plus 1. And that says, I don't know, 3x squared minus 1. I want you to take a derivative of this and use a power rule. And we're going to tell you that which situation you have to use product rule. There's no distribution going on.
Mr. Yin, technically you could use just the definition of a derivative for like everything we've done so far, but we just use these things just to like make
No, we no longer use definition derivative. Definition derivatives teach you understanding how it's from secant line to a tangent line. Now from now on, you got much better way to do it. You got power rule, you got product rules. Yeah, you don't want to use definition derivative anymore because it's gonna be you use too much time on doing something so repetitive, and not all the time you can resolve anything.
Yeah.
So like that's the homework, x plus h to the 5/2 power.
Yeah.
That one is gonna be much easier to use power rule because if you use simple algebra, it's not gonna get an answer. You guys finish taking note of this? You should get 2. 3x squared minus 1. And then plus 2x plus 1 times 6x. Did you do that?
Yes. Yeah.
So you should get 6x squared minus 2 plus 12x squared plus 6x. So you should get 18x squared plus 6x minus 2. I think that's a final answer? Okay. Okay. So I'm going to show you distribution doesn't always work, especially you combine algebra and trig. So let's just take the derivative of x squared sine of x. Now, is it possible for me to distribute this? No, because the argument is right here. This x is untouchable. Nobody can distribute outside inside to become sine of x cubed. That doesn't work that way. So x squared and sine of x are each individual function. So why you need to use product rule? Like this situation. It could be e to the x times sine of x. It could be natural log of x times sine of x. Any transcendental function and algebra combination or any type of combination of any different type of things is going to require product rule. Distribution only works strictly in algebra. It doesn't work with any other places. So therefore, if I do this, then I'm going to take a derivative of 2x sine of x plus x squared cosine of x. You have to do product rule, and there was no way around them. Life is like that. You have to learn to be versatile. Not only know how to do a job. You're not going to be nobody with a job. Does that make sense? Now, knowing the difference between product rule and constant multiple rule is also very, very important too. So let's just say if I have a function that says y equal to 2x cosine of x minus 2 sine of x here, and I say, hey, let's take a derivative of this, y prime. Where is product rule? Where do you use product rule? Give me a second, Danny. I need to ask other people. Ilya, what do you use product rule here?
As in, say it again. Where or
Where do you use product rule?
for the 2x cosine x?
Exactly. Now, how about 2 sine of x? Remember, it's not two functions. 2 is actually, it can be a function, but it's just a constant more likely. So 2, it doesn't count as 2 and sine of x. Can you use product rule? Yes, you can, but it will be x so redundant, almost useless. So here is where the product rule occurs. So this is the product rule. Here is called constant multiple rule. It's called constant multiple rule. Why is it called constant multiple rule? Because just like 2x or 2x squared, derivative of x squared is 2x. The 2 just in the front. All you gotta do is take derivative of sine of x, cosine of x, and you're done. So here product rule again, it'd be 2 cosine of x plus 2x times negative sine of x. You're done with the first part. And I'm going to take a derivative of 2 sine of x, which is constant multiple rule, will be 2 cosine of x. And that's it. I'm done. Besides that, I might be able to cancel this too. And the answer is equal to negative 2x sine of x. So product rule happened here as well as constant multiple rule. You're going to say, can I do product rule with this? Yeah. Derivative of 2 is what? 0. Sine of x. And then leave 2 alone. Right? Derivative of sine of x equal to cosine of x. Still same thing. But do you need to do that extra term? Not necessary. I think constant multiple rule will be the best.
So you don't do it because it's like 2 is not a function, and you can only do it with 2 functions.
Yeah. I mean, you can. 2 technically are a function. It's just derivative of 2 is 0. So there's no reason to do product rule when you have 2x squared. Do you see what I'm saying? You can just use constant multiple rule because you do to the x squared. There is no point to do product rule of this. If you do product rule, are you going to get 4x? Yeah. You leave the 2 alone and take a derivative of the x squared, so it'll be 2x. And plus x squared and derivative 2, which is 0. Guess what? It's still going to get 4x, but it's so unnecessary. And they're still going to do this, but it's so unnecessary because you now recognize when to use what rule. Yes.
What makes x squared sine x 2 functions? Why isn't it just one?
What makes 2x cosine of x or 2 sine of x?
Look at the top, like x squared sine x, the example.
Yeah.
What makes that two? What makes that two functions and not just one?
Because they're not able to join together. There's no way for you to distribute each other. They are two separate things. They are multiplying x squared to the sine of x.
Okay, so. Oh, okay. So you can't. So that the reason that like 2x squared is one function is because you can't distribute the two.
Can you distribute the two?
You can't to x squared.
Yeah, but just two times, but not into the x squared. You cannot say it's 2x parentheses squared. Right? You cannot say it's parentheses 2x squared. That doesn't make sense. So they are two separate things. One is constant, one is x squared. So that's a constant multiple rule here. Now I'm going to talk about one more rule. It's called quotient rule. What is quotient rule? Quotient rule in math is a fractions. Okay, so if something quotient with something, so 2 quotient 5 is going to be 2/5. So that means if I take a derivative of some function over another function, it's going to create a quotient rule. And the best way to memorize is this acronym. It's called low d high minus high d low over low. Now, I'm going to write it here. I'm going to do it accordingly. So this is the high function, which is, high. And this is low. So I'm going to start with the low. G of x, f prime of x, because I take a derivative of the high, minus high d low and all over low. And that's it. Now, what people usually forget is the bottom part. Don't forget the denominator. If I grade all this paper, people usually forget the denominator. They forget the square, so don't forget square. Don't forget the square. And don't expand the bottom. Don't expand the bottom. Never help you if you expand the bottom. So don't try to be cute. Says I can expand the bottom, and you don't have to. So let's just say if I want to take a derivative of this, 3x squared minus 1 over 2x minus 5, something like this. There are two functions. I remember the acronym. You start with the low. Derivative to the high. What's derivative to the high? 6x. Minus high d low over low. Over low. Don't expand the bottom. Keep it 2x minus 5 squared. Do not say it's 4x squared minus 20x plus 25. Almost no reason to do that. Why factor form is better than other form? Because factor form is going to tell you immediately where the vertical asymptote is. Expand them, you still have to factor back to see the vertical asymptote. So almost no need. Now you can simplify the top. So be 6x, no, not 6x, 12x squared minus 30x minus 6x squared plus 2 over 2x minus 5 to the square. So that's equal to 6x squared minus 30x plus 2 over 2x minus 5 to the square. Don't forget the bottom. you're gonna take a derivative of this function, and then we are pretty much done today. 5x minus 2 over x squared plus 1. Learning how to take a derivative.
Wait, how'd you go from that to the 5x minus 2?
No, I'm just that's just a new question.
Oh,
So this is a new question. This is a practice. You are gonna take a derivative of 5x minus 2 over x squared plus 1.
top we always have to expand it.
Yeah, top expand, bottom don't.
We can't cancel.
Nothing. You cannot cancel. If you cancel like this, you kill a kitten. That's bad.
We can't do that.
No, I know you have every tendency to do that, and I'm gonna show you. You kill a kitten, and you don't believe me. You can actually just search up kill kitten, and just say math, and look at an image, and it will show up this. Every time you do this, a kitten die, and just don't kill a kitten because you cannot cancel the x squared and x squared. If you're adding something, you cannot cancel. If something is multiplying something, let's say 2x minus 1 times x minus 1 over x minus 1, x minus 1 can cancel. But if you're adding something, they cannot cancel like that.
Yeah,
Okay. You like cat?
Yes.
Okay, don't kill them.
Yeah, I have a question. On the previous, can you go back to the previous one? You know how you got the answer 6x squared minus 30x plus 2 over 2x minus 5 squared?
Mhm.
Could you, like, let's say, like, 6x squared minus 30x plus 2, and you factor that, and, like, a factor of that would be 2x minus 5.
And you can cancel them.
You can cancel it.
The only in that time you can cancel.
Okay, so, like, if you are able to factor the top, that cancels with the factor on the bottom, then you can cancel.
Yeah, almost not. You almost never happen. I would say almost never happen
Okay.
is because it'll be a very cool question to prove. Like I have done a lot of question before. I never see anything can cancel the square. The only time you can see that is you doing the second derivative. If you're doing a derivative again, that there is possibility to cancel. Oh, or when we're doing chain rule, there's a possibility you can cancel them. And but as of right now, no. So let's see if you do the product quotient rule correctly. So this is a practice of 5x minus 2 over x squared plus 1.
Sorry, just go just a little bit again.
Sure.
Just, yeah.
Or if you have problem, remember low D high minus high D low over low low. I remember sad phase every time I see quotient rule. So it's gonna be like I think about drawing. So you start from low, go to high, right? And you draw a line here. So low D high minus high D low. Chef, you didn't come to school today. Over low low. And just like it's drawing a sad face. Every time I think about quotient rule. Now my favorite rule to go to, and we're going to talk about how do you avoid them, when you can avoid them. Chef, first period is not good for you. You just come to school just now at 6th period?
No,
What period you come to school?
I was late to that.
You're just, maybe Martin is better than you. At least Martin show up.
I showed more than her.
No.
Yeah.
No, she had excuse. She was she got in, her dad got in car accident. Her mom she got in car accident. Yeah. Actually, a lot of shit happened to a lot of my students. So her dad got total. She got a car accident. Her sister got in a car accident all in 1 month. And I just saw Yasil. Yasil's house got burned down.
What? What?
Yeah.
The house got burned down?
Yeah, the whole kitchen is gone. And he showed me a picture. I was like, holy, there's a lot of things happen. Okay, anyway, what's the derivative of this? Low d high, did you do this? Minus high d low, and don't forget the bottom, and don't forget the square. And you can expand the top. Minus 10x squared. And plus 4x, I think.
Yeah.
Over x squared plus 1 to the square. So it'd be negative 5x squared plus 4x plus 5. I don't know if this one's factorable. No, I don't think so. Okay, when to avoid quotient rule though? I'm going to talk about 3 situations you should avoid quotient rule. Yesterday's first question, you should avoid quotient rule. First situation, if the denominator is equal to 1 term. For example, yesterday's homework, 3x squared plus x minus 4 square root x over square root x. Imagine do quotient rule with this. It's not pretty. It's better to split them before you do quotient rule. Make sure you realize that. Don't use quotient rule at this situation. Why? You could have split them, so it'd be 3x to 3 over 2 plus x to 1/2 minus 4, and then you take a derivative from here. It's much more efficient than quotient rule, because quotient rule of this one, it's kind of messy. Square root x times 3x squared plus x minus, it's going to be, square root x times 6x plus 1 minus 4 times 1/2 x to the negative 1/2 minus 3x squared plus x minus 4 square root x times 1/2 x to the negative 1/2 all over x. It's just disgusting. So this is the moment you should avoid quotient rule. Second moment you should avoid quotient rule is bottom's 1 term. So denominator equal to number. So if this over 2, then do not do quotient rule, because you can technically take out the 1/2 in the front. And you can take a derivative from here, just leave the 1/2 in the front. So that's going to be 6x plus 1 minus 4 times 1/2 x to the negative 1/2. And that will be done already. You avoid the quotient rule when the bottom is a number or 1 term. So those 2 situations. There's a third situation too, but we're not going to mention when we go to the chain rule. I'll see you next time.